This is Brendan Walker and Evan Wells' 32-bit fixed instruction processor programmed on the Altera DE2 board. Here we have our instruction memory preloaded with 9 instructions and our data memory with the given data at the required spots. If we go over to the DE2 board, we see the hex displays display the program counter, the state, and the instruction register.
When we press the clock button, it will move to the next instruction. So previously we're in the initial state, and now we're on the decode state. From the first instruction register, we have 21B0 telling the processor to load word from the data memory 1B and load it into register 0. The next state for this will be state 4, which is our load word. So if we press it next, it'll move to state 4, and the next one will move to state 5. Now in state 5, it will load it to the register.
So we click the clock button again, and we go back to the fetch state. Fetches the next instruction, which is again a load word given by the 2, and it's loading from data memory location 2A into register 1. Again, we see the decode stage goes to load stage A, load stage B, back to fetch, where it fetches the next instruction.
This process repeats a few times until we have loaded all the words from our instruction memory. When it's finished loading, our next instruction is to subtract from register 0 and register 1. This is done at the next state, which is 8. So going to state 8, our ALU A is 216BA, and our ALU B is A04E. Subtracting those two will develop a 816C from our ALU. Moving on to the next state, we will do another set of subtraction from registers 2 and 3 and load it into 5.
Again, the next state will be 8, which is a subtraction, and we have the data from register 2, which is 71AC, and the data from register 3, which is B17F.
And then our ALU output will be CO2D. Hitting the next button, we will
We'll fetch another instruction, which will be an add instruction. We'll add register 4 and 5 and store it in register A.
In the ALU, we will have the 816C from register 4, and B will have from register 5, we'll have CO2D, and the ALU will output a 4199. This instruction will be loaded or stored in our instruction memory or data memory, which is the next state will be a 6. This state once it's at state 6, it will be uploaded to our data memory.
in real time. Following the store instruction, our next state will be to decode the next instruction, which is opcode 5, corresponding with a halt, and we halt operations.
If we wanted to reset this code, we'd press the clock cycle and then the reset button, which is on key 2, and it'll reset our state to 0, which will reset our counter. And that's all that we have.
And that's it. It's working.